Let's work on the next part of your review for your CRVA Part 1, Chapter 1 test. So find the inverse of each function. In the inverse section, you'll need to find the inverse of a function, and then you'll have to evaluate the function at a value. So the problem you're going to be given is, the problem will give a function like f of x equals 3x minus 5. So just some function f of x, and you'll be asked to find this. It'll say find that. So first you have to find the inverse of the function, and then you have to plug 8 into the inverse function. This means inverse function. So back to my red circle, this means the inverse of the function, and it means our input is 8 in that inverse function. So let's find the inverse of this initial function. So not speaking of inverses, remember we could rewrite this equation y equals 2/3 x plus 2. I did not start the inverse process. F of x means y. So now let's try to go and get the inverse. So to get the inverse, we switch x and y. So now it'll say x equals 2/3 y plus 2. And now we solve for that new y. So we subtract 2 and subtract 2. We get x minus 2 equals 2/3 y. And now to get y by itself, the next step is we undo multiplying by the reciprocal, which would be 3/2. So the left side we have to multiply by 3/2. So our new inverse function is y equals 3/2 x minus 2. And again, that's my inverse, so I really should mark it this way, noting that it's the inverse with that inverse connotation f of -1. There we are. Now if they wanted the inverse function evaluated at 8, we would just plug in 8 in the inverse function. And so when we simplify that, we're really just doing the work on the right side. My left side is telling me that it's the inverse function evaluated at 8. I'm not going to switch colors for this. All right, so then we get 10 in the parentheses, and we get 30 over 2, which is 15. So that is the solution to this. There is all of this work to get the inverse function, and then you plug in the value. Let's try number 13. So again, this looks like, really I'm thinking y equals x plus 4. That's what that initial f of x function is. But now to get the inverse, I'm just going to draw a little line. Now I'm going to work on the inverse. So now I switch the x and y. So x equals y plus 4. And now I solve for y. Well, all I have to do is subtract 4 and I'm done. Y equals x minus 4. But let's rewrite that with function connotation. So this is the inverse function. All right, the inverse of f of x is x minus 4. So now let's evaluate it at some number. I'm going to choose 8, but really it doesn't, like, they could choose 10 and then you just put in 10 in place of x. So you get 8 minus 4. The inverse of the function evaluated at 8 is 4. 4 is the solution to this. Let's keep trying that a little more. Again, we could think of this as y equals -2/5. I like to put the negative sign up top. So now let's go after the inverse. So let's switch the x and the y. So x equals -2/5 y plus 2. And so to solve for y now, we'll subtract 2. So we get x minus 2 equals -2/5 y. And to undo multiplying by negative 2/5, we multiply by negative 5/2. Remember, a negative times a negative is a positive. So I need this negative right here because it undoes the negative right there. So we end up with a positive y. Of course, what we do on one side, that's right, we've got to do on the other. This whole right side gets multiplied by negative 5/2. So let's write this really nice and neat now. But I'm going to actually put the y on the left side. So y equals negative 5/2 times x minus 2. But let's rewrite this in function connotation. This is the inverse function. There we are. And that's evaluated at a number. What number should we choose? They'll tell you what number to choose. I'm going to choose 8 just to... I don't know why. Just choosing 8 today. So now we just simplify this, and so we get 6 in the parentheses. Geez, you also end up with, well, now it's negative 15. That was an answer earlier. All right. All right, one last time here. We're out of space. All right, so again, I'm just thinking in my mind, this is like y equals, you know, you could rewrite this as negative 2/5 x, and then 10 divided by 5 is 2. I'm going to rewrite it that way. All right, so now let's switch the x and the y and go after the inverse function. So x equals negative 2/5 y plus 2. Switch the x and y. Start solving. Did I did I just switch the x and the y twice? That's silly. That is silly. So we're going to subtract 2. We get x minus 2 equals negative 2/5 y. Multiply by, whoa, this is the exact same function as this one. They just didn't simplify it. Right. Holy cow. All right, anyway. Multiply by negative 5/2. This should seem familiar. It's good practice, right? And then rewrite it in function connotation. And let's change the input to 8. And you'd get the same value as before, the negative 15. Well, that was silly, huh? Last one. So again, I'm thinking, now there's plenty of space. Now I'm thinking y equals 1/2 x plus 3/2. But to get the inverse, we're going to switch the x and the y. So x equals 1/2 y plus 3/2. So I'm going to subtract 3/2 first. So on the left side, I have x minus 3/2 plus, equals 1/2 y. To undo multiplying by 1/2, so we can get y by itself, we get 2. So we're going to multiply all of this by 2. So we get y equals 2 times x minus 3/2. And now, folks, in this case, in these examples before, I could distribute right here, but ooh, that's messy. It's actually not quite as messy as, there's some benefits to distributing that through, but it can cause just as many or more problems. Like here, I could have distributed 3/2 through, and actually it would, yeah. So I'm going to choose, you don't have to do this, but actually it will make things a little easier here. When I distribute it through, I get y equals 2x minus, take this 2, multiply it by 3, it gives you 6. Divide that 6 by 2, you're back to the 3. In other words, this 2 that I've written in black, multiplying the 3 by 2 in black and dividing the 3 by 2 down below, multiplying by 2 and dividing by 2 cancel out. So that's why we have just a 3 there at the end. But let's rewrite it. I got excited. Nope. Let's rewrite it in function notation. So the inverse function of f of x is 2x minus 3. Now let's plug in a value. So let's evaluate the inverse function of f of x at 8. So plug in 8 for x, and you get 16 minus 3 is 13. Boom. There we are. Evaluating the inverse of a function at a value.